Hi, gang. Welcome to week 6. I want to check in, say hello, go over a couple of our assignments for this week, give a short lecture, and then check out. First off, please know I'm working to get caught up on grading this weekend. There's a lot of things due on my plate that are bigger projects that take away from grading right now. So I apologize for not getting those back to you, a little bit more quickly, but I will do my best. I think I don't have to go out of town this weekend. I don't have to teach. So this should be a good weekend for me to get caught up. So look for a lot of your discussion boards and assignments to have grades on them by this weekend. The let's see, there's the textbook. Let me go into this week because there were a couple of questions. So this week we're starting module 4, even though it's week 6. Yes, we take more than 1 week on each module sometimes. And so we talk about probability and sampling. There are a few items in here to help you understand this. I also have a basic scoring assignment. And that this is the thing that you're doing this week for credit. So I'll just cut to the chase. The anxiety poll, the state trade anxiety index. So you're going to need this to be able to do the scoring assignment. So if you download this, it will actually give you the items from this day, and it will also give you the scoring, the way that you score these things. This is important for anybody going to be a researcher, going to use a psychometric assessment. A lot of them are created in similar ways. Again, this is an older one. It's from 1983. We're going on 41 years of this day. It has been shown to be a valid and reliable instrument even today. So I do encourage you, well, I don't encourage you, you're required to take the thing and then reflect on it. I didn't want to make it to where we were all sharing all of our scores. I wanted to preserve a little bit of anonymity for you. So if you're really high or low in state trade anxiety, you don't have to broadcast it for the whole world in the class. So I made this into an assignment. And here's where you would want to upload a file, I would argue. And the way that you would want to make this, I would argue, is to make an Excel document. I know I took the test and did it this way. And I'm sorry, I'm looking at an Excel document on my other screen. I'll pull it over there in just a second. So the way this would look is that there's a trait anxiety and a state anxiety score. I think the stay is actually first. So let me start with this. So you'll have state anxiety and then trait anxiety scores. State anxiety would be very temporary. So the way that you answer these questions is 0 through 3. So you have a possibility of answering 0, 2, 3, 0 for each one of these. So these would be 20 questions on each one of these, the state and trait anxiety. Please, here's the trick. Some of those are reverse scored. That's on the instructions for the stay. That is one of the tricky things that you have to make sure that you do as a researcher. If things are reverse scored, otherwise your instrument is completely invalid. It's not reliable because you're not scoring it the way that it was intended. So before you go and interpret your scores, make sure that you reverse score the items that are necessary. I'm gonna let you figure out how to do that as graduate students. And if you need to use the discussion board for that, you're welcome to. And that's what the discussion board is for, to help each other out if you have questions. If you're just completely stuck, I would encourage you to reach out to me. Let's go to the lecture and the notes. I'm going to go to the book. So the book tries to align with the lecture and the notes. It's still chapter 3. And and I'm moving over to page 75 of our textbook. A lot of this we've already covered prior to this in the chapter in previous weeks. I like this decision tree. So how do you interpret a raw test score? So let's say that you get this state trait anxiety index score for yourself, and it's a raw score. you can see that the authors of this STAI have given a, low anxiety, moderate anxiety, high anxiety. So you can kind of see where you're at in that regard. But there are also other ways that you can look at that number score, and there are quite a few ways that you can look at that number score. The one thing that I want to pay close attention to is normalized scores. So if you go into something called Z-scores, these are standard scores, and it's a way to tell where you or a certain score on a test lies in a bigger distribution of scores. Remember, we fundamentally base most of our statistics on the understanding that most phenomenon occur in something that looks like this, a normal distribution, a bell curve. You can see this illustration was IQ, which we went over earlier this semester. Here's the demonstration of a positive skew. Here's the definition of, or an illustration of a negative skew. However, most data, when we do our statistics, we assume that it's gonna fall, the distribution, when we put all the scores together, then average them. It's going to look like this. We're going to have an average score in the middle, and we're going to have a score here that's one standard deviation below, another standard deviation that's two below. I'm going to use this, hopefully if I can write on this screen, to illustrate Z-scores. So an IQ test has been run, we've used IQ for 100 years and really, to have a very standardized understanding of it. If I were going to translate these scores here to Z-scores, there is a formula to transform that. This would be a Z-score of 0. So if I have a Z-score of 0, it's right on the mean. If I have a Z-score of -1, it's one standard deviation below the mean. If I have a Z-score of -2, it's two standard deviations below the mean. If I have a Z-score of -3, it's three, and so forth. You can see, and on the other side, your standard deviation on this test, SD equals 15. You can see there's 15. But if you translate that and you do the formula, you run the formula, and then you transform that number into a Z-score, this would be a Z-score of 1. This would be a Z-score of 2. This right here, if it fell in the middle, 122.5, that would be a Z-score of 1.5. You can see that we transform things to make better sense to where they are in that distribution. So it gives you a very quick visualization to understand. Then if we're talking about Z-scores, I think if I wanted to give you something really complex this week, I'd say use your own STAI. I'd give you the overall, the distribution of the stay, and then talk about standard deviation, and then find where you are with your state and trait anxiety. So here's the formula to transform standard score, Z-scores, transform raw scores into Z-scores. You have to have the standard deviation to be able to figure this, to figure out this data. So anyway, so converted standard scores. Again, it gives you a way to visualize the data, and then you can also figure out percentile ranks based on that. So if you were to score in the, and again, I'll try to make sense of this as best I can with the little amount of time possible. And I'll go over this reference again. It takes a little bit. If you've never had this illustration, it really simplifies statistics, and it makes it understandable where, okay, I can have this visual map and understand what's going on. If I were to draw lines right here, let's say I draw a line straight on the 100, or the Z-score of 0, and on the 85, the Z-score of -1, 34% of all scores would be between -1 standard deviation and the mean. If I were to do the same thing on this side, if I draw a line on 100 and then I draw a line straight up from 115, that's a Z-score of 0 and a Z-score of +1. 34% of everybody in this distribution that was sampled is in this percentile. So you could see that if I had a score, so if you think, 34% below, 34% above one standard deviation, 68% of your sample is really hovering right around the mean right here in this quadrant, in this block right here. If I were to go for then a percentile rank score, and you again use this visual of this of this normal curve, if I were going for percentile rank, a score of 115 would then be, let's see, if we take 50% plus 34%, a score of 115 would put this person in the 84th percentile. So if a person scores 115, they're in the, there are 83 people out of 100 below them in a percentile rank. If we took a z-score that's a z-score plus 1. So if you assume a standard deviation, which most statistics are built on this assumption of a normal distribution, and the standard deviation score, the z-score is 1, anybody who has a z-score of 1 is at the 84th percentile. Same thing here. Let's say you have a person with a z-score of 2. Well, we know that you have 34% of data here, 34% of data here. There's 68%. There's another 14% here. 68 plus 14 is 92%. And then you have another, yeah, I think that's right. Then you have another 2% out in this tail. So that gets to 94%. Let's see here, adding this up. 2, 14, 16, 1634. I need my calculator. It got too complicated for me. Come on, calculator, follow me up. All right, 2 is in 2% out here in the tail, plus 14 is in this standard deviation, -1 to -2 z-score, plus 34% here, plus another 34% here, plus another 14% here, comes up with 98. So we know that somebody who's got a z-score of 1, 2, a z-score of 2, they're in the 98th percentile, which means they're really, really high up. There's 97 people below them on a score. If you had 100 people. I hope that helps this make sense. I love this as a student because it was something concrete that I could hold on to help me make sense of statistics. If that didn't make sense, then reach out to me. I'll draw something out that's not in our textbook, but I did want to go over that. I felt like that's a very important concept to understanding stats and why we do what we do and how we're doing it. But anyway, I'll be reaching out soon with grades. Otherwise, do your assignments and we'll stay in touch. See you soon.